So in the previous lecture, I was talking about general adversarial networks, but now we condition it on some class, some feature, something that is important and is informative and expressive. So this paper in 2014 So generative adversarial networks that I explained in the previous video were recently introduced as a novel way to train generative models. So in this work, we introduced the conditional version of generative adversarial nets, which can be constructed by simply feeding the data we wish to condition on both the generator and discriminator. We show that this model can generate mnist digits, condition on class labels. For example, all images that are 1. All of them that are 1. We also illustrate how this model could be used to learn a multimodal model and provide preliminary examples of an application to image tagging, in which we demonstrate how this approach can generate descriptive tags which are not part of training labels. Generative adversarial nets were recently, so I talked about it. So now, multimodal learning for image labeling. Despite many recent successes of supervised neural networks, it remains challenging to scale such models to accommodate an extremely large number of predicted output categories. A second issue is that much of the work to date is focused on learning one-to-one mapping from input to output. However, many interesting problems are more naturally thought of as probabilistic one-to-many mapping. For instance, in the case of image labeling, there may be many different tags that could appropriately apply to a given image. And even different human annotators may use different terms to describe the same image. But one way to help address the first issue is by using natural language corpora to learn a vector representation of labeling with geometric relations are semantically meaningful. When making prediction in such spaces, we benefit from the fact that when prediction errors, we are still often close to the truth. So for conditional probabilistic generative model, the input is taken to be conditioned on variable, and the one-to-many mapping is instantiated as a conditional predictive distribution. So you see, this is the original two-player min-max game with this value function, and this is the idea of previous video. It was GANs. But now we are just condition on y. Everything is the same. Just condition on y. Then you have a discriminative, a generator of your sample z. Condition on what you want to condition. And again, we sample z from that distribution that is very random, and then we sample x from data distribution that we have a specific distribution of your, for example, images, real images, for example. But z, we want to create a generator, a synthetic image, for example. So you see that we just condition on y. Even for the discriminator, we need that information. Because even at the discriminator, you see this y. So we condition on y, and the rest of that is just GANs. So each row is conditioned on one label. As I said, this row just conditions on, for example, class 0. This one is class 1, and so photo sites such as Flickr are a rich source of label data in the form of images and their associated user-generated metadata. So we pre-train a convolutional model similar to a previous lecture. So you see the generated tags and the user tags annotation and generated tags. So even is important for generated tags.